Okay, when we're working with matrices, what we're dealing with is an array of elements within a matrix. So that array is arranged into rows and columns. And the things within a matrix we refer to as elements. And we generally do that with a lowercase. And then whatever the lowercase letter is, in this case we've got A's, we deal with an uppercase in terms of what the matrix actually equals. So over here, in our top left corner we've got 1, 1, top right 1, 2, bottom left A1, A21, and bottom right A22. And these addresses come from the rows and columns. So if we have a look, this is row 1 and this is row 2. This is column 1 and this is column 2. So that's why this here is 1 and 1, while this one is 2 and 2. Now we said the order of A is a 2 by 2. Now this idea of order is really important when it comes to adding, subtracting, and multiplying matrices. So if we're trying to add matrices, so I've got two here, example A, which is 1, 2, 3, 4, and B, which is 5, 6, 7, 8. Now that's got 2 rows and 2 columns. This one has 2 rows and 2 columns. So that means we can add them and we can subtract them. If they don't have the same number of rows and columns, so if they're different order, we cannot add and we cannot subtract them. So for this case, and then what we do when we add, we add the elements that are in the same location. So over here we're going to add 1 and 5, 2 and 6, 3 and 7, 4 and 8, and we put those in the same location in the entry matrix. So A and B are both 2 by 2, so that means A plus B has to be 2 by 2. So we put that in there. So we'll say we've got 1 and 5, so we'll say 1 plus 5, and then 2 and 6, so 2 plus 6, bottom left 3 and 7, so 3 plus 7, bottom right is 4 and 8, so we have 4 plus 8. We'll close it off, and next line we'll let it equal, so 1 plus 5 is 6, 2 and 6 is 8, 3 and 7 is 10, and 4 and 8 is, let's make sure I write that 10 properly, 4 and 8 is 12. So that's how. And subtraction works exactly the same way, except that rather than adding numbers, we subtract them. Now, if we've got a number multiplied by a letter, so like we've got here 3b, that means we're multiplying every, this is what we call scalar multiplication. So that means whatever is inside of b, we're multiplying it by 3. So to rewrite this, what we do, we've got 5, 6, 7, 8, so we'll make this 3 times 5, 3 times 6, 3 times 7, and 3 times 8. From there, what we end up with, and I'll put the answer to the right, is 15, 18, 21, and 24. So that there is scalar multiplication of two matrices. Now, if we're going to multiply two matrices together, it's a little bit more involved than what we've seen. And if anyone has a shortcut or any way we can make it a bit easier, I'd love to hear about it. So right here we've got A times B. Now, we've got to check the order of the matrices. So we know A is a 2 by 2 and B is a 2 by 2. So that's what we're going to write down. So A is a 2 by 2 and B is a 2 by 2. Now what we're looking for is these two in the middle. For us to be able to multiply the matrices, those two things have to be the same. In this case, they are. Now also, these two numbers make up the order of the answer. So the answer matrix will also be a 2 by 2. So once again, these two have to be the same. These two have to be, is what the answer will be. So over here, we go through our multiplication, and we do, it takes a little bit of time to get the hang of, it takes some practice, but you do get there in the end. So what we're going to do is we're going to multiply the top row by the first row by the first column, and the first row by the second column, second row by the first column, second row by the second column, and that's what's going to make up our 4 elements within our resultant matrix. So we've got 1 and 5, so put in 1 times 5 plus 2 times 7. So that's where that comes from. Now we're going to do the top row and the second column. So we'll have 1 times 5, 1 times 6, my mistake, 1 times 6 plus 2 times 8. Then at the bottom, we go through it again. So we do 3 times, so we've got 3 times the first row, which is 5, plus 4 times 7. Then we do the same thing, except we do it across the second column. So we say 3 times 6 plus 4 times 8. And then we go off and we add these together. So we end up with 1 times 5 is 5, plus 2 times 7, which is 14. 1 times 6, which is 6, plus 2 times 8, which is 16. 3 times 5, which is 15, plus 4 times 7, which is 28. And we've got 3 times 6, which is 18, plus 4 times 8, which is 32. So now from there, we'll end up with 19, 22, 43, and 50. And as promised, we've got 2 rows, and we've got 2 columns. So our answer is 2 rows by 2 columns. So there we have identifying a matrix, labeling a matrix, matrix addition, scalar multiplication, and then matrix multiplication there as well.